We're gonna investigate these types of equations. These are the equations that Excel gives you. It's a form of an exponential equation. In this equation, which is up here, y equals a times the irrational number e raised to the k, which is the rate, times the number of time periods. So the difference here really is just b, instead of having a times b raised to the x, you have a times e to the rate raised to the x. This one here actually would be 22.3% increase. We use this is continuous increasing. And I'm going to just explain the difference between compound increases and continuous increases. And then I'm going to get into this formula in a little bit more depth. Okay, so let's look at compound versus continuous. There's a continuum there too. The continuum is just FYI. The beginning point is our first equation, and our end point will be this equation, which then we will explore. Okay, so I'm gonna move from, I'm gonna take a certain amount of money. We'll take, say, like, $1,000. And we're gonna invest it for 2 years under these different scenarios. Scenario 1 means I'm going to get 7% every year for 2 years. So that's compounding, right? Compounding every year. So these are, you've probably seen this in the homework. It's the same equation, right? Initial value, rate, in this case, time period. This is more often used for money, but it's the same equation. So let's put in our values, all right? So let's use this one. Copy it down here and put in our actual values. So my output equals my initial value times my rate. Hopefully you know 7% increase, 1 plus 1.07. And this is going to be for 2 years. And put that in your calculator, and how much money do you get? How much money is that worth after 2 years? And I'm getting 1,144 and 70 cents, or 90 cents. Okay. So that's our basic formula we've been using. This one is used for money. This is a little different. What this is taking 7% and compounding it every month, okay? Not every year, every month. So watch how I fill this in. Now, you're not responsible for this, and if you would be, I'd give you the formula. Don't worry about it. I'm just showing something. As we move from compounding yearly to compounding monthly to compounding continuously. So this is, again, my $1,000. That's my initial value. 1 plus the rate is, this case, it's 0.07. But I'm not going to get 7% every month. This is how many periods in a year. I'm going to get 12 periods in a year. So I'm not going to get 7%. I'm going to get 1/12 of 7% every month. And this is 12 months, and that is 2 years. Now you can try putting that in your, putting that in your calculator and see what you get. And I'm getting 1149.81. Which is more than I got by compounding it yearly, which makes sense. Because every month you're getting a little bit, and then the next month you're compounding on the interest you got from the month before. Now this is how your credit card companies charge you, believe it or not. And what this is continuously compounding. That doesn't mean every minute. It means every millisecond of every minute of every hour of every day of every year. So it will make a difference. It's going to be more than compounding monthly, but we'll see what it is. So again, A is the initial value. In this case, 1,000. E is an irrational number on your calculator. It's equal to about 2.7 something. So it's just a number like pi. My rate is 0.07. That's how you put the rate into this formula. And the number of years is 2. So put that in your formula, in your calculator. Should have an E button if you have anywhere near of a calculator, and see what you get there, and I'll put it up. Whoops, it should be 0.07, right? 7% as a fraction. And I'm getting 1150.27. And that, of course, is dollars. And that is continuously compounding. Now, some things are continuously compounded. And we're going to explore the relationship between how to derive this and how to derive this.